Namaste and welcome back to this LCD series. In the previous video, we explored the internals of the PCF8574 I/O expander and the HD44780 LCD controller right from their datasheets. Today, it's hands-on time. We will connect the ESP32 DevKit and bring the LCD to life by displaying characters live on screen. And just for fun, we will even try to display this custom message in Japanese. Coming up next in the series, we will tweak this same code just a little and run it on an STM32 board. So stay tuned and let's get started. At Avinashi Tech, we bring embedded systems to life. One wire, one byte, one project at a time. If you are into hands-on builds, deep dives, and code that actually makes sense, hit subscribe and join the tribe. Here, I have the source and header files organized for this project. I2C.h and I2C.c handle all low-level I2C operations. LCD_I2C.h and LCD_I2C.c contains functions specific to the LCD display. If you ever want to port this code to another microcontroller, all you really need to carry forward are these two files, LCD_I2C.h and .c, with just few minor changes. Let's open up LCD-I2C.h. Here, you will find macro definitions for LCD commands, flags, and in the end, some function declarations. In LCD_I2C.c, make sure to update the header files based on your particular platform. Since we are using ESP32 with the ESP-IDF framework, so we include ESP32 specific headers. Next, update the macro delay, which will be needed for microsecond accuracy. So we use ETS_delay_microsecond function for ESP32. For debugging, we use ESP_log_i as a substitute for our print macro. Obviously, on STM32, for instance, you can use HAL_UART transmit. Then we have the macro I2C master send data. And in this, we have master send data function, which eventually acts as a wrapper function and calls the final I2C master related APIs. And for initialization, we define macro to call I2C init directly. But on platforms like STM32, you might need to pass a I2C handle. So with few changes in this particular file, you are good to go. Alright. Let's now take a quick look at I2C.c file. So we set I2C frequency, configure SDA and SCL pins, and then define I2C init and master write slave function. Back to LCD I2C.h. Here we define command macros. Let's say, for instance, display control, which is 0x08. So according to our datasheet, this command controls display, cursor, and blink. So flags like display on, off, cursor on, off, and blink on, off are defined in the code based on their particular bit positions. Let's go back to LCD underscore I2C.c file. So in this, we have LCD begin function. Here, we implement the initialization sequence to set the LCD into 4-bit mode. Once in 4-bit mode, each byte is split and sent as 2 nibbles over P4 to P7. The send function handles the split, and it is called from function command for LCD commands and LCD underscore write for character codes. Expander write function handles I2C writes, while pulse enable function toggles the enable pin, just like this timing diagram for 4-bit data transfer shown in the datasheet. We also have a function createChar, which is used to define custom characters by writing to CGRAM address. Each pattern is a set of 8 bytes for a 5x8 dot matrix. Alright, let me go to our main source file and our main application. In this, we call LCD underscore init function with our display size, that is 16 cross 2, 16 columns and 2 rows. Then we turn the backlight on and call our LCD home message function. So first we display Namaste and welcome to at the display position which are specified here. Remember, every time we call set cursor, it sets the DDRAM address for that character position. Then after a short delay, we display our channel name Avinashi Tech on line 1. Now we load our custom icons into CGRAM using createChar function. The byte array for this are mentioned in the start. We used an online tool called LCD Character Creator to create this byte array. Just select hex output, click the dots you are interested in, like a heart or like, and copy this 8-byte array, and you are good to go. So we then write this character codes 0 to 3 using LCD write function. Remember our relation between DDRAM character code and CGRAM character pattern, right? So at column 6, we have our subscribe icon. Then at column 7, we start writing subscribe. At column 3 and 4, we display our share icon. And at column 1, we show the like icon. Alright, let's quickly sum it up. Even if things didn't fully click so far, just focus for the next couple of minutes, lock in your attention, and catch these key points. That's all you really need to move ahead. So you should understand that when we call set cursor, what we are doing is we are setting the DDRAM address, as we have discussed in our part 1. So first, you write the line of code set cursor. After that, if you call LCD write or send string, which eventually calls LCD write in it, so no need to worry about that. So set cursor sets DDRAM address, and after that, if you go with LCD write, that sets the DDRAM data. So remember, set cursor, DDRAM address, LCD write after that gives DDRAM data. Now let's go to createChar. So in createChar, the command is setting the CGRAM address, and if you call LCD write after that, that means CGRAM data, right? So here command CGRAM address. After that LCD write CGRAM data. So here CGRAM data would be 8 byte data, 5 cross 8. Remember, if you have seen the part 1, if you haven't, go back and refer it. So LCD write here will be writing 8 bytes for a particular character. Now, after we have written to the CGRAM, no need to again call create char. After that, if you want to print it, set cursor, which will now be DDRAM address, LCD write DDRAM data. So here 3 is correlated to the specific string that you have, or specific character pattern that you have created in the CGRAM address. So plain and simple, no need to stress. If you don't understand anything else, just focus on this few key aspects. Clear? Now I just flash this to my ESP32 and we will see how the display is. So here I already commented it in a way so as to make you understand that exactly what row and column this particular data would be. So N, then A, then M, A, S, T, E, space, and ampersand. Then in the next line, how is next line set? Set cursor 0, 1. So that is setting the first row and 0th column. All right. So here we have W, space E, and up to O. All right. In the next, after waiting for a certain delay, we again clear to clear the display, set cursor 0, 0. Then we send the string 0, 0 means this place. And then look how we called 10, 0, not 0, 10. 10, 0 is telling that at that particular column 10 and row should be the same, that is 0. We want TECH or tech. Then we will do with 5, 1. So 1 here is the row, 5 is the this particular column. So we will have the subscribe icon and then subscribe sentence. So at 5 we will have the subscribe icon and then the subscribe word. So that's likely. Then in the end we have 0, 1. So 0, 1 is this particular place where we have the heart symbol. All right. So here I have our hardware with us. We have the LCD 2x16 display with us. Then we have this PCF8574 module, the I2C IO expander, our ESP32, micro USB cable, and obviously some loop on cables. So let me just connect it. The connection's pretty simple. Just need to get this PCF IO expander at the bottom of this particular LCD. Okay. After you do that, you have 4 pins to connect with ESP32. So I have connected VCC to VIN on ESP32, that is 5 volt, ground to ground, SCL to D22, and lastly this SDA to D21. This is it. Pretty simple. No rocket science. Just after this connection, you upload the code and you are good to go. Let me open up terminal and let's flash this code. There it is, Avinashi Tech. So that was ASCII characters. Now I would like to make a special mention that I went one step ahead and even experimented with the Japanese Kana characters. Let me show you. So as we discussed in the part 1 about the ROM code A00 and ROM code A02 and how they had Japanese characters as well as some European characters. So let me show you what we talked about. Let me just comment this section out. Now suppose I want to express that character. I will do is set cursor, so DDRAM address 0, 0, and then LCD underscore write DDRAM data. So that is at 7 is the lower byte, sorry, and upper byte is B. just flash this to my controller and see if the character appears or not. Alright, so let's see. So N now changed to that particular character. Why that happened? Because we missed clear. Alright. Anyway, you get the point, right? So I even thought that why not display this message Avinashi Tech and then heart, share, like, share, subscribe icon, and also this subscribe in the Kana character. So I experimented and went on to some translators, English to katakana. I'm not sure how to pronounce that, so pardon me for that. And I went with Avinashi Tech. So that gave me this character. Now, since I'm not at all familiar with the vocabulary, so I opened up a Kana chart. Now the thing is that sometimes it is very hard to represent a character in 5x8 format. So that's why you might not be able to grasp a particular character instantly. That's why this Kana table would be helpful. That is how I decoded and tried my best in accordance to what the translator said. Made this particular array of channel name, that is Avinashi Tech, and subscribe message, that is subscribe in Japanese, using all of this character code which is available here. So for example, let's say the first one, that is this. So we have 0xb1, so that is 0xb1. So similarly, alright, now let's go with clear, set cursor, and now instead of this send string, let's say we have a message. What we are doing is calling set cursor, so that goes with DDRAM address, and then LCD write, that calls with DDRAM data. So DDRAM data is the character code as we already discussed. So if you do not remember or if you have not seen part 1, I do recommend you to have a look at it. Alright, let me just, sorry, I missed size off here. There we are, the message in Japanese Kana characters. So I have a request, if anybody who is Japanese or is proficient in Japanese is watching this video, do let me know if this particular word or characters are correct, and if they're not, just help me out with that in the comment section. So I guess that's it for this video. So in this video, what we learned, so we went through all the header files and source files that are needed for us to implement this 2x16 LCD display with a microcontroller. We went through all the major macros and the functions that we need to deal with. And in the conclusion, I even helped you out with the shortest thing to remember, that is set cursor function, LCD write function, and create cat functions. So this was our journey with ESP32 and the LCD display. But wait, there's more in this series. In the upcoming video, we will take our STM32F4 based black pill, and this development board would be used to implement this 2x16 LCD display based code. And remember how we talked about it, that we just need to tweak some minor macros and some header files in order for this code to be easily reusable. That is what we will be doing. So hang on tight for that as well. Now that we have a complete message on our LCD, what are you waiting for? Like this video, share it with your friends, and subscribe to Avinashi Tech. Signing off.